In today's video, we're going to be going through a few questions from the Chapter 3 review. Just like the other review videos, we don't have time to go through every single problem. Otherwise, this video would be very, very long. But I'm just going to hit on a few of the problems that are a little bit more tricky to help you make sense of those. I would highly recommend, as you'll see as you start on this review, I would highly recommend reviewing some of your basic derivative rules like your power rule, chain rule, product rule, quotient rule, because you will see those on the exam just in connection with taking your derivatives of your exponential functions. So also review the exponent rules for exponential functions, right? If you take the derivative of e to the x, what do I get? I just get e to the x. But what if I take the derivative of e to the kx, right? What if you have a constant? What if you have a constant up there with your x? You just get k e to the kx. So review those derivative rules so that you're good to go when you actually take the exam. But the first problem that I want to go through with you guys is number 12, specifically because part D is a little tricky. The first three parts are relatively straightforward because it's all just building your exponential equation and using that exponential equation to find values. So part A is asking you to find the exponential equation given two pieces of information. In my case, in 1964, postage was 3 cents. 3 cents for a stamp. And then that has increased by the time we've reached 2010 to 27 cents. If we consider that exponential growth, we can then create an exponential function to model this growth. Okay, so if I wanted to write my exponential function, it would be, right, my actual amount is equal to my starting value. Well, I guess in this problem they use S. So I'll use S. What's my starting value, though, in this case? It tells you, go ahead and assume that your starting is 1964, or whatever year it gives you. So that means, what's my initial value? 3 cents. And I'm going to write this equation in terms of cents. This is going to be in terms of cents. Well, if I assume this is exponential growth, I know I can write e to some rate times t. I don't know what my rate is. How am I going to find my rate? I'm going to use my other point. So this is what I'm going to use in order to find my rate. 27 cents represents a stamp value, so that's what I'll plug in for my output. And then I'm going to plug in how many years has passed since 1964. Well, from 1964 to 2010, I can just subtract those and I can get 46. 46 years have passed. Well, if I go ahead and solve this, divide by 3, take the natural log of both sides, I get that my rate is equal to the natural log of 9 over 46, which when I plug that into my calculator, I get about 0.0477. Okay. What's nice is part A is just multiple choice, so I'm going to go ahead and pick the option for me. The option that best matches is 3e to the 0.05t. Okay, 0.05, that's what I get when I round this up. When I round this to 2 decimal places, I get 0.05. Okay, so there's my equation, right? We have my initial value and then my growth rate. And part B just asks you, well, what is that growth rate in terms of percentage? To get that as a percentage, so this is part A, part B, all I have to do is just move that decimal place over 2 times. If I move that decimal place over, I get that this is a 5% growth. It's growing at about 5% each year. Okay, part C is just using this equation to estimate. And it even specifically tells you, use your answer from part A. So use this equation to estimate what this postage is going to be in 2018, 2021, and 2024. How do I do this one? Well, this one's simply plugging in t values into my function. So for 2018, I'm going to plug in the t value 54, because it's been 54 years since 1964, right? You can find that by doing 2018 minus 1964. That's 54. And for me, I get about, it tells you to round to the nearest integer, so I get about 45 cents. Okay? For 2021, I'm just going to plug in t equals 57. And for 2024, I'm going to plug in t equals 60. Right? So all this means is I'm just taking these t values and plugging them in for t in my equation and calculating it out. So for 2021, I get approximately 52 cents. And 2024, I get approximately 60 cents. Now, D is where it gets a little confusing, and so that's why I'm going to kind of help you out and walk you through this. So it says, the Forever Stamp is always valid as first-class postage on a standard envelope weighing 1 ounce or less. That's how Forever Stamps work. So let's say we have an advertising firm that spends 20, or that always buys about 10,000 stamps each year. So it always needs 10,000 stamps a year. So if we think about what it cost for them in 2009, it cost them $2,700, because that's 27 cents times 10,000. So what it wants me to do is compare, because this advertising firm has two different options. It can keep buying 10,000 stamps every year, but if they do that, prices are eventually going to go up. Their other option is to go ahead and buy all of the stamps they need in 2010. For the next, in my case, we're looking at 2010 to 2025. So in this range, we're just looking in this range. What this question is asking is, how much money will the firm save if they purchase all of their stamps in 2010? Well, let's start with that one. That one's the more straightforward one. In 2010, how much do my stamps cost? My stamps cost, okay, so let's look at 2010 right here. In 2010, my stamps cost 27 cents. And what we're going to do is we're going to go ahead and purchase all of the stamps I will possibly need from 2010 to 2025. Well, how many years is that? 2025 minus 2010 is 15 years. But what that doesn't count is that doesn't count 2010. So we have to be careful. If I just do that, it does not count 2010. So I'm going to add one more year in order to count 2010. So there's 16 years worth. And if you're confused about that, count it out on your fingers. Start with 2010 and then 2025, and you'll see that it's actually 16. So 16 years are passing. How many stamps are they buying each year? 10,000 stamps a year. So what am I going to do with those two numbers? I'm going to multiply them together. That gives me 160,000 total stamps that I'm buying. Okay, so I'm buying 160,000 total stamps. And what's my price of each stamp? My price is 27 cents per stamp. So I'll go ahead and multiply those two things together. See what I get. 160,000 times 27 cents is, I'm going to get I'm going to get 4,320,000, but remember that's in terms of cents. So if I move that in terms of dollars, I'm going to get $43,200. Right? I just moved the decimal place over twice, right? Divide by 100 in order to get it in terms of dollars. Okay, so that's how much money they spend if they buy all of their stamps in 2010. They're going to spend a total of $43,200. Well, like I said, their other option is to just go ahead and buy them year by year. The important thing to understand here, so that's option 1. This is option 2, which is buy every year. This option was buy in 2010. Well, the important thing to recognize is if you read the problem closely, it says assuming there is a postage increase in each of the years 2018, 2021, and 2024. So the answers we got in part C represent when there will be a postage increase. So the postage will stay the same price until it gets to these 3 years, and then the price is going to jump up. So that means how much money are they spending in 2010? Well, they're buying 10,000 stamps at 27 cents a piece, and that gives me just double check. Yeah, that gives me $2,700. Okay? So that's just for the stamps for 2010 because they're only buying 10,000. Well, 2011 will roll around. Has the price increased? No, price is still the same because the price won't increase until 2018. So stamps are still 27 cents. I'm still buying 10,000, so that's going to be another 2,700. And it turns out that's the same for 2012. That's the same all the way up until 2018 hits. So all the way through 2017, all the prices are going to be the same. It's costing them $2,700 each year. Okay. So if I don't want to add all these together, I can just look at how many years is this? 1, 2, 3, 4, 5, 6, 7, 8 years. This is 8 years at $2,700 a year. So I can multiply those two. So for the years 2010 to 2017, I spent a total of $21,600. Okay? Because that's what I got when I multiplied these two things together. Or if I added all of these together, right? If I summed all these up, I would get $21,600. Okay, so that gets me through 2017, but why did we stop there? Because the price bumps up in 2018. So what are we spending in 2018? In 2018, I'm still buying 10,000 stamps, but the price has increased to 45 cents. So I'm going to multiply this by 45. What does that give me? That gives me 4,500. So in 2018, I have to spend 4,500 on stamps. What about 2019? Same price, right? So same amount. So 2019, same amount. And 2020, same amount. What about 2021? That's where another price increase happens. So we'll wait to do that one. So from 2018 to 2020, that's 3 years. So my total is equal to just 3 times 4,500, which is 13,500. Okay? Next. $2021. I still need 10,000 stamps, but now the price is increased to 52 cents, right? I can see that right here. That's what I got in part C. The price is now 52 cents, which means my total price for the year is $5,200. How many years am I doing this? 2022, same price. 2023, same price. And then my price jumps up again at 2024. So just for these 3 years, which means for 2021 to 2023, my total is equal to 3 times 5,200, which is equal to 15,600. Okay, last. 2024, my price bumps up. So to get 10,000, I still need 10,000 stamps, but now the price is 60 cents a stamp, which leaves me with $6,000. Costs $6,000 to buy all my stamps in 2024. Since I'm going through 2025, that's just one more year of $6,000. And so my total for 2024 to 2025 is just 6,000 plus 6,000, which is 12,000. Okay, so those are my totals for each of my, oh my goodness, that's not what I wanted to do. Those are my totals for each of my kind of years, breaking it up for when the price jumps up, right? That's why we had to break it up into these different pieces, is because the price was changing at certain times. So how do I get my total that they spend on stamps this way? I'm just going to add all these totals up. So I'm going to do 21,600 plus 13,500. Oh, geez. Oh my goodness. Plus 15,600 plus 12,000. So let's see what we get. I get $62,700. So the total amount they spent using option 2 is $62,700. How much do they spend in option 1? They spent $43,200. So what's my difference? I can just subtract those to figure out how much would they save if they just bought all the stamps in 2010. Okay, and I get $19,500. So that is my final answer, $19,500, and that's what I'll put in for Part D, right? That's the difference between how much they would have paid if they bought all their stamps in 2010 versus just buying 10,000 stamps each year with the price increases. Okay, the next problem I want to look at is number 15. Okay, this problem is talking about a product whose sales are declining, and they're declining exponentially. And so it gives me a few different values, right? It gives me that in 1984, 203 million products were sold. And then in 1994, 1.4 million products were sold. Okay, and this problem is pretty similar to the last problem we looked at in how I'm actually going to write my equation. So remember, I wrote my equation by plugging in the points to actually solve for what my rate was. So here I'm going to be solving for what my rate is. Because this is exponential decay, what should I expect to be true about my rate? My rate should be negative. So sure enough, if I do the work, I'll see that my function ends up being my value is equal to 203 e to the negative 0.497673 t. Okay, I'm not rounding very much to just keep this as accurate as possible. And that's what I get. So I want to point out some things before we keep going. So this is part A. I want to point out some things before we keep going. First of all, there's my initial value. My initial value is the amount that was in 1984. So what does that mean about T? T equals years since 1984. All right? How many years have passed since I first started looking at it in 1984? The other thing I want you to notice about this 203 is I kept it just in terms of millions of dollars. So that means V is going to be in terms of, not dollars, V is going to be in terms of millions of products. How many products you're selling. And it's all in terms of millions. Okay. So, part B, if I wanted to answer part B is just asking how many products are being sold in 2002. Okay. Well, 2002 is 18 years since 1984. So all this means is I'm going to plug in T equals 18 into this function. See what I get out. Okay. Remember, though, that your answer is going to be in terms of millions of products. So if it wants the answer just rounded to the nearest whole number, it's going to want your answer completely written out. Not in terms of millions. It wants it completely written out. So write it out first and then round to the nearest whole. Okay, remember millions is 6 decimal places. You're going to move the six extra zeros, 6 decimal places. Well, C is the part that I wanted to specifically go over because this one can be a little confusing. This just asks the question, how long will it take before only one product is sold in a year? Well, notice how that question is reversed. What am I solving for here? I'm solving for T. And what does it give me? It gives me a V value. But specifically, what is my V value? If I plug in 1, you will get this answer wrong. Because if I plug in 1 for V, remember my equation is in terms of millions. So that will solve for how long is it going to take before I'm only selling 1 million products a year. So if I want to get this in terms of millions, one product is equivalently, move that decimal place 6 times, and I get 0.0000001 million products. Right? By moving the decimal place, I now have this in terms of million products, and I can go ahead and plug this into my formula. So I would plug this in. And then solve from there. Now remember, whenever you're solving for the variable that's in the exponent, what will I eventually need to use here? I'm going to eventually need to use a natural log to solve for this. So the last problem I wanted to talk about is number 23. Now you may be panicking right now thinking, last problem, we only did 3 of them. That's right, because once again, if I did more than 3, this video would last just that much longer. So to keep it relatively short, we're only going to do 3 problems. If you have any questions on any of the other problems, please let me know. Please reach out. But the reason I picked these 3 problems is each of them, there's a part on it that's a little bit more tricky than normal. Whereas the other ones, I feel are fairly straightforward, that if you are watching the previous videos, looking at previous homeworks, looking at your own notes, you should be able to figure them out on your own. Number 23, though, I want to talk about this one just from this very first part. This is an amortization problem. So I'm purchasing a home for $225,000. I'm putting 20% down. The time, it's a 25-year mortgage. So T is going to be 25. And I find there's a 6.6% interest rate. Okay, and that's, of course, compounded monthly because I'm doing monthly payments. Okay, now the first problem is similar, or the first part of this problem is similar to the first part in numbers 21 and 22, where all it's having you do is just select what formula we're going to be using. And in all of those, you're just selecting the amortization formula that I showed you in the 3.6 video. But what this problem does is it changes it up a little bit. Instead of using R and N, it uses I and C. Don't be thrown off by this. I just represents the interest rate. And C, it just represents the number of times it's being compounded. C for compounded, I guess, and I for interest rate. So all they're doing is switching up the variables, but it's the same exact formula. I'm still going to be putting 0.066 in for I. I'm still going to be putting 12 in for C. Okay. And in this problem, what am I putting in for T? T is going to be 25. And what's my P going to be? Is it the 225? Remember, I'm putting 20% down. So what I have to do first is I have to do 225,000. And I can do this one of two ways. I can just or I can calculate this straight out by just multiplying by, if I'm putting 20% down, then my loan is 80% of the 225,000. You can also do this by calculating what your down payment is by multiplying that by 0.20 and then subtracting that from 225. In either case, you should end up with 180,000. 180,000 is what my actual loan is going to be, and that's what goes in for P. That's all it really is to that problem. At that point, it's just like your normal amortization problems, just like 21 and 22, so you should be able to handle it from there. Once again, please reach out if you find yourself struggling on any of these other questions, and I'd be happy to walk you through them or give you some tips. But good luck on this review, and good luck on the Chapter 3 exam.